Hi and welcome back to another video. We are in the beautiful UK. As you can see, we are greeted by nice UK weather with a little bit of wind and a little bit of rain, and I hope you can understand me fine. But we are going to visit this fascinating data center behind me, which is a new place from IONOS. We are in Worcester, the city that's pronounced completely different than what it's written. That should be really cool, but I think we will just hop inside because it's just too windy. The reason why we are again visiting a data center were mainly your comments. By now we visited different hosters, different data center providers to just get an overview of how different data centers are built and what these specific companies are experts in. And after doing multiple of these videos, we often had feedback about is the heat of the servers reused and where does the energy come from? How can you make this kind of energy more sustainable? So with that feedback, we reached out to IONOS again because we just shot a video with IONOS in Germany, and they said, yeah, we have exactly something like that in the UK. And that's how we ended up here. And one of the most modern data centers in existence right now, it's a tier 4 data center, which is also the highest certification you can get for reliability of data centers. But in today's video, we will not focus so much about the servers. Like we have a Dell EMC for data storage right here, and there's a huge amount of SSDs right next to me, and obviously you have a lot of different Intel servers and AMD servers and all of that. We will not cover this in big detail today because it's mainly going to be about how could you run a data center as sustainable as possible. Right now we are in another cold aisle, and left and right of me we have all those bare metal servers that are also in-house designed by IONOS. We just visited them in Germany for a different data center tour. Unfortunately, we didn't have that video in English. You can still check it out in the German channel with subtitles, I guess. But all these bare metal servers right here are also in-house designed by IONOS, so they use their own rack design and own server design to make sure they use the space as sufficient and efficient as possible. One of these racks right here can be supplied with a maximum of 11 kilowatt of energy. We have two huge server rooms in this data center right now, and each of the rooms can be supplied with about 650 kilowatts. So a total of about 1.3 megawatt for the entire data center which we're visiting today. And we will now jump into where does this energy come from. We're starting right from the beginning. Next to me we have huge circuit breakers, and they are delivering 11 kilowatt, so 11,000 volt from outside to the building, then goes through those circuit breakers and then to the transformers. Those 11,000 volts will then be transformed with this transformer from 11,000 to 400 volt. And this has a capacity or a power of about 500 kilowatt. And just so you have a bit better orientation of what we just looked at, how it looks here. So we just started in the building outside. That's where the 11,000 kilowatt arrived. They go all the way underground to here. They arrive here, and you can see this red thick cable underneath me. And if we follow this, then we go all the way to where we've just been in the transformer building. This tier 4 certification, what I talked about earlier with this 99.995 availability, is something you can only get if you can maintain full availability, and that starts with the infrastructure. That's also why everything which we see right here with the circuit breakers and then starts with the transformers, all of this also exists on the other side of the building, again full scale. This will be from a different energy supplier with a different power line and everything, to make sure that if something happens that's maybe not even related to the data center, then they can make sure that they always have power. And in case power fails, you obviously have to make sure that you can maintain power in case of a power outage. And that's why you have all those generators right here. And typically in such data centers you would have diesel generators. They kind of are diesel generators, but they use a very interesting fuel. In case power fails and the generators are required to start, there is a small gap that it takes for them to be on full power, and that's typically between 30 and 60 seconds. And to make sure that the power will not be out for 30 or 60 seconds, we have the UPS. And part of the UPS are the batteries. And we have one stack right here. And the entire data center, if it's running on full load, can run about 20 minutes just on batteries. And obviously, this is not a huge amount of batteries next to me, because this room right here, where we are standing in right now and filming, exists 8 UPS rooms. And only 4 of them are technically required to make sure that the data center is running. So technically, 4 of them could fail and nothing would be a problem. In this current setup, the energy is always flowing through the batteries, like all the time. And IONOS has some internal workshops where they're currently trying to improve efficiency of the data centers so they consume less power to just save energy. And one of the projects right now is to change this system, to change from running through the batteries all the time to something like a parallel operation. I'm not sure how exactly this works, but they're going to change it to make sure it's even more efficient. And right next to me, we can take a look at this UPS. If we check the status of this, it tells us that it's running on 22% load, which is about 57 kilowatt, or now 59 kilowatt. And we can check that with this kind of load, which is about a fourth of what it's capable of, the battery would last 1 hour and 12 minutes if required. And obviously, again, everything is about redundancy. And that's the same thing for these, I would call them massive radiators. They're not really ACs because they don't cool down inside, but they're supplied with cold water from outside. And this cold water is used to chill the room. And on everything which we're looking at, all the devices, you have different color codings. So on this one, we have red color coding. On this one, we have the green color coding. And that's always for redundancy, in case if one of those cooling units for whatever reason fails, because also the UPS has to be cooled and the batteries. Well, the batteries technically might also be necessary to heat them up, because you don't want them to be too cold. You want to make sure that they're always at room temperature, because cold batteries have less capacity and are more easy to damage than if they run at the required temperature. And we can also take a look at this right here. Here we can see that we run on about 60% humidity inside here, and the cold air that is used from the cold water inside is supplied with 22.3 degrees Celsius, and the returned warm air after it exits from the UPS and the rest in this room will come back with about 22.8 degrees Celsius. These rooms obviously also are equipped with a lot of different detection systems, warning systems. For example, on top right here, this is part of the fire detection system, because it's constantly taking in air and then trying to detect if there are some specific particles in there, to just check if something starts to burn before it actually starts to burn. Technically, those devices can even detect if just the capacitor blows up. This also exists in all the different rooms, but we will skip this because we already showed this in a lot of different videos in the past. We are back out. You can see sunshine, it's beautiful. And we're standing right next to the generator, and this is actually a bit smaller than what we saw in the previous video when we were visiting IONOS in Berlin, because this is only about 550 kilowatt of power. But what makes this especially interesting is the fuel it's running on, because it's running on HVO, which means it's a hydrated plant oil. And a hydrated plant oil means that it's any kind of oil, fat that can be used, like leftovers from restaurants, or like any kind of plant oil you can use, and you treat it with hydrogen, which is required because any kind of natural oil contains oxygen, nitrogen, sulfur maybe, and this is everything that you don't want inside a fuel, like compared to a diesel. And that's why it's treated with hydrogen to remove all of those particles. For example, the oxygen will be bound with the hydrogen, and then it will just be H2O. And then that will be removed later on, and this way you clean any kind of natural oil, and it will have the same kind of burning properties like a diesel. And what I find fascinating about this is if you take into account that ideally this generator never runs. Ideally there is never a power outage, and it will never be required to run this. Which means that they still spend a lot of time and money and effort to have this like CO2 neutral, like just sustainable, even though they might never use it. And that's the spirit I find so fascinating about this data center, because just looking at the scale, it's a smaller data center, but the amount of effort they put in even into those tiny details, in this case the HVO, to make it more sustainable, is definitely interesting. This tank has a capacity of about 7,700 liters, which is fine for a constant use full load of about 3 days. But obviously, as a tier 4 data center, they have their contracts, they have their fuel suppliers. So in case the generator starts running, they just go on the phone, call the fuel supplier, and it takes a few hours for them to get a lot of trucks lining up here, so they can theoretically run for an infinite amount of time just on this fuel. One thing that those buildings, data centers, usually have is space, especially on the roof. And in some of the previous videos, people were wondering, why was the space not used? IONOS equipped the entire roof of this data center in Worcester with a photovoltaic system. More than 1,000 modules allow to compensate a lot of the power consumption, especially in summer when you have high temperatures and you have high cooling needs, directly on site. And compared to the full year, they can produce more than 10% of their own power consumption directly with the photovoltaic system, which is equipped with a peak performance of 524 kilowatt. And as a comparison, that is more than what 50 normal houses would provide if they are equipped with a photovoltaic system. The focus of IONOS on sustainability already started in the planning phase of the entire building. So just the steel frame itself was also involved, because this steel is carbon neutrally produced. This entire thing, the entire building is, it's surprising what kind of level they pay attention to when it comes to this, for example. So it's basically just some place where you can store your bikes, so it's protected from rain, for example. And then somebody decided to put these things in here, which is basically to provide some shelter for insects. That's kind of fascinating. I mean, I tried to find a bug I can interview about his stay near the data center, but I think it's just interesting to see what kind of little things you could do in theory. The DC voltage, which is generated on the roof, comes down through the wires in this shielding on the wall, and then comes down in the individual DC wires, and then just goes into here, which is just a normal inverter, then converting the DC to AC 400 volt again. And the 400 volt, those are those big lines, power lines, going all the way on the bottom. They will go around the building here and then will be fed into the system. We just left the UPS room, and you will remember the big chambers in the background where I was explaining that they are responsible for cooling down the air. And that is also what we can monitor on here. Obviously, they have different kind of overlays and different kind of monitoring levels where they're monitoring everything that's about the infrastructure when it comes to electricity and the cooling and all sorts of things like that. And for example, right here, this would be one of those chambers that were just standing behind us, and then we can monitor the temperature, the cold air intake or water temperature, humidity, because they have to make sure that over the day, like all the time, they have the same conditions inside the data center. And you also saw it in the video that might just be a little bit colder in the morning, then it starts raining, then you have sun, and you have to make sure that you control accordingly, that you have the same conditions inside, no matter what happens outside. Same goes for the cooling. On some day you might have the free cooling, some day it might be too warm, and you need the chillers to cool down the water in addition. And that's why we'll just hop outside to those chillers quickly. We are now back outside, but on the different side. So that's the stuff we haven't seen yet, but I also want to show that this actually exists. And if we go down here, we have the pipes, the cold water pipes. So that's where the cool water accesses the data center, then flows through those chambers and through the heat exchanger, and then comes back slightly warmer. So enters here at about 20 degrees Celsius and comes back out at like, I don't know, 23 degrees Celsius maybe. And then right here we have a chiller that is responsible for cooling down the water. And it depends on the outside temperature if this is running on free cooling or just the normal chiller mode. Obviously you would always want to use the free cooling mode, which means that you're just cooling down the water directly over the cold air that's outside here, the ambient temperature. But once this exceeds about 19.5 degrees Celsius, then the chillers have to run in the normal chiller mode. And one interesting aspect about this was again the Tier 4 certification, and that's where this big thing comes into play. That is a huge reservoir, and I just thought it would be a normal reservoir for maybe the entire water loop. That's maybe necessary, but I mean, this is already quadruple redundant, so if this fails, there are still a lot of other chillers that could jump in if something goes wrong. But also, if there's nothing else left, then there's this big tank that contains cold water, which is usually just inside the cold water loop. And if everything fails, this can be used again to cool the chiller if that's necessary, like if everything else fails. And that's just an additional thing that's required for the Tier 4 certification. And if we would continue on this side, that's exactly what I was talking about. This is already what we've seen on the other side. Double exists on here, and it already double exists on this side. So we have quadruple of everything. We have those tanks, we have the chillers, and we have the generators that are again, or theoretically would be powered with the hydrated plant oil that's sitting inside those tanks. We have the transformers and everything. Just exists a huge amount of times just for the Tier 4. Now switching back to the solar production on the roof, because they have this nice slide that shows how much power they produced over roughly the previous year, because the building is roughly a year old. And you can see they produced 387 megawatt hour just with the solar system on the roof. And that's capable of covering a huge amount of what they're actually consuming as power themselves. Now they provided another very nice chart to us that shows the power production of the solar panels on the roof, because you've seen in our previous footage of probably for you today, but we were filming on 2 days, and on the first day the weather was not great, as you could see. It's like, it was fully cloudy, not a single piece of sun was visible, and you might think that it's not really useful to have a solar panel on the roof in that case, but that's not true, because even at that day, because that's why we pulled exactly that data, you can see we had a peak production of 100 kilowatt. And if you think about the cooling requirements, which we just showed with the chillers and everything, even on a fully cloudy day, you can cover the chiller load just with the solar panels on the roof. And then if you transition to a warmer and sunnier day, let's say for about a week ago, they had during the day peak above 300 kilowatt. And even during the day, average is probably 150, maybe 200. And peak, they even had days of about 400 kilowatt where they even had to throttle down the power of the solar panel, because they are not allowed to produce more than what they actually consume. They cannot feed it back into this in the external system. And that shows that having such a system on the roof is definitely something that's really good to have and should be something that data centers should have for the future. Especially if we look at this nice data on the bottom, they also kind of calculated how much CO2 emission this saved, and they have this figure of 82 tons equals 5,000 planted trees. Not sure how that's calculated, but I did a quick calculation of the 82 tons of CO2 emissions. If you take a normal Volkswagen Golf, and that consumes about 140 grams per kilometer that you drive it, for 82 tons, you can drive around the Earth about 15 times. Just to give you an estimate of how much CO2 emissions they already saved in the first year, and then still take into account that the first year, I mean, they're not really utilizing the building fully. And especially long term, if you think about that such a building will run for tens of years, I don't know, 20, 30, 40 years, I'm not sure. But for the full lifespan that the building is used and the solar panels are used on the roof, you save a huge amount of emissions. And especially during like hot summer days where more cooling is required and you have a lot of sun, you can counteract all the increasing power draw of your building, which is a really cool thing. So much about this data center tour, which was not so much about the data and the servers, but much more about the infrastructure and how you can make this entire topic more sustainable for the future, because that's what I read in so many comments under our previous data center tours. That's why we shot this video in cooperation with IONOS. So thank you again for having us and being so open and showing everything, even live power consumption numbers, stuff which you don't usually see, which was amazing for us to get access to. And also this should be very interesting for the future, because right here I have some servers next to me, and right now I'm getting all the warm air blown into my face. But right next to me on this side, everything is empty because I said right now it's only half populated. And IONOS is right now working on to also going into water-cooled servers, which will also open up more possibilities, because right now the hot air that is coming out from the servers cannot really be reused because the air is warm but not hot enough to maybe utilize it for something else. This can be different with water-cooled servers, which is also something else they're looking into, and probably something we're also looking into once they have it up and running, so that should be interesting. And apart from that, I think it was interesting to see what kind of ways you can find to make a data center more sustainable with the solar panels on the roof and having this HVO fuel instead of normal diesel fuels, all those tiny parts coming together. And that's probably how the future is going to be for data centers. IONOS is also using 100% green or renewable electricity for their server farms right now, and they're also committed to fully reduce their carbon emissions by 2030. And that's probably where the future will be for data center hosts. So much about this more like renewable energy focused video when it comes to data centers. Thanks for tuning in. See you next time. Bye bye.